Ladies and gentlemen, we are looking at note 6.4, which are on surface area and volume of cones. Before we do anything, I want to write down the formulas that we derived in class together, and we're going to use the formula sheet to write it down, but again, it's what we figured out as a class last time I saw you guys. So the surface area for a cone is pi rs, where r is the radius and s is the slant height, plus pi r squared. So we'll go ahead and write that down. So surface area is pi rs plus pi r squared, okay? Remember the lateral area, which is just the outside piece, and it doesn't include the base, is just pi r s, because the area of the base is the area of a circle, so it'd be pi r squared, okay? And then lastly, the volume of a cone, if you look at your formula sheet or you remember what we derived, was 1/3 pi r squared h, okay? All right, awesome. So in question number 1, it says calculate the surface area and volume of the cone shown. Since it says the surface area, it's the full surface area, so we're going to use the full surface area formula. But taking a look at this, I want to identify what R, S, and H are. Okay, so it tells us that the full diameter is 3.5, so the radius is going to be half of 3.5, so our radius is going to be 1.75 centimeters. Okay, it tells us here that the slant height is 9.1, and it tells us that the height, the actual height from the center of the base to the vertex is 8.4 centimeters. Okay, so to find surface area, I'm going to do pi rs plus pi r squared. So here I end up getting surface area is pi times the radius, which we figured out is 1.75, okay, times the slant height, which we figured out right here is going to be 9.1, so we're going to say times 9.1. Oops, sorry, I'm just trying to color code this, times 9.1, okay, plus pi times the radius again, which we know is 1.75, but I'm going to square that value, okay? So I'm going to leave the pi's for right now, and I'm just going to say surface area is equal to, and instead I'm going to multiply 1.75 by 9.1, and I get 15.925. So what I'm going to do is I'm going to treat this pi kind of like a variable. So I'm going to write down that this ends up being 15.925 pi plus, and then I'm going to do the same thing for this 1.75. So I'm going to take 1.75, I'm going to square it, and I get 3.0625 with the pi left over, okay? Then it's like we have like terms here. We've got 15.925 pi plus 3.0625 pi. And when I add those together, 15.925 plus 3.0625, I end up getting 18.9875 pi. So my surface area is going to be, like we said, 18.9875 pi. This is my exact answer because pi is irrational and it goes on forever and ever and ever and ever. We will have to at some point in time start to round because there's no way we can put all the digits if they're going to have infinite digits in our answer. So an approximate answer will be what I get when I actually multiply it by pi and round my answer. So I'm going to take 18.975, multiply it by pi, and I get about 59.65, so on and so forth. Now, it doesn't say what to round to, so we'll round to the nearest whole number, and we'll say that it's about 60 square centimeters. So we're going to say this is about 60 centimeters squared. So that's going to be our surface area. Now, to find the volume, we said we're going to take 1/3 pi r squared h. And here we know that the r is 1.75. So I'm going to plug in 1.75, and I'm going to square that Then I'm going to multiply it by the actual height and not the slant height. And the actual height that we have here is 8.4. So I'm going to multiply this by 8.4, and then I'm going to put this in brackets again, and I'm going to go from here. So I get V equals 1/3 pi times, we figured out 1.75 squared, but let's do it again. 1.75 squared is 3.0625. So this is times 3.0625 times 8.4. Now, to keep going, to find the exact volume, I'm going to take 3.0625, multiply it by 8.4, and I get this value, but then I have to take 1/3 of that value, which means I need to just divide by 3, so I get 8.575. So that means that the volume, the exact volume, is 8.575 pi, and that would be, again, our exact volume because we didn't do any rounding yet. Multiply that value by pi, and I end up getting 26.939. When I round it, it ends up being about 27 cubic centimeters. So this becomes approximately 27 cubic centimeters. Okay? Number 2, Tracy makes her own frozen yogurt treats in cone-shaped paper cups. They have a height of 12 centimeters and a radius of 4 centimeters. So these pieces of information that we have here are super important. Okay, so question A, determine the volume of the frozen yogurt treat to the nearest cubic centimeter. So as we know, to find volume, we're going to do 1/3 pi times the radius squared times the height. And I'm going to draw a picture of what this is going to look like. So here is the radius, and then when I draw it in, this right here is the height, and the radius is 4 centimeters and the height is 12 centimeters. So I'm just going to fill in that information. So I'm going to say 1/3 pi times the radius, which is 4, so I'm going to fill in 4 right here, times the height, which is 12. Okay? So then when I go ahead and I multiply all of this information out, I end up getting 1/3 pi times 16, because 4 squared is 16, times 12. Now I'm going to multiply 16 times 12, and then, oh, let me try this again, 16 times 12, I get 192. And then I'm going to divide it by 3 because that's the same thing as multiplying by 1/3. So I end up getting 64. So this right here ends up being equal to 64 pi. Again, this is the exact answer, but it says round it to the nearest cubic centimeter. So I'm going to take 64, multiply it by pi, and I end up getting 201. So it's approximately equal to 201 cubic centimeters. Okay, and then part B says determine the amount of paper required for the cup. Now, if you guys can picture it right here, when we fill in the frozen yogurt, there's not going to be a cover to the cup. So that means that we only want to look for the lateral area, or the lateral surface area, because we don't care about the top circular base that we have here. And that's what this pi r squared piece is. So we only need pi rs. So we know the radius, but we do not know the slant height. We actually have to calculate it. And if you guys notice right here, we have a right triangle. And in our right triangle, right here, we have 4 here. This is 12, and our slant height is the hypotenuse right here. So I'm going to use Pythagorean theorem to calculate the length of the slant height. So I'm going to say a squared plus b squared equals our slant height, s squared, okay? And just make sure if you use s, you don't get it confused with 5s. So right here, sorry, let's start with c squared actually. And then here, when I fill in my information, I'm going to say 4 squared plus 12 squared is equal to s squared. So 4 squared is 16, 12 squared is 144 equals s squared. When I add those two together, I end up getting 160 equals s squared, which means that s is the square root of 160, which is approximately equal to, and let's go ahead and calculate this. So let's just double check all of our work is correct. 12 squared plus 4 squared is 160. I'm going to square root it, and I'm going to have a bunch of digits for this so I have a more accurate final answer. So I'm going to say 12.64911. Okay, so right here, 12.64911 is going to be my slant height. Now, to find the lateral area, I need to use the formula pi r s. And I know that the radius is 4. So I'm going to fill in 4 for my radius. And I know that the slant height we figured out was 12.64911. So I'm going to fill in 12.64911. Now, at this point in time, there's no way I can get an exact answer if I'm going to use this as my slant height because we rounded it. If I plugged in square root of 160, then it would be an exact answer. So I'm just going to go ahead and type this into my calculator. So I'm going to take pi, I'm going to multiply it by 4, then I'm going to multiply it by 12.64911, and I end up getting about 159 square centimeters. So the lateral area is approximately equal to 159 centimeters squared. Okay? Right, number 3 on the next page says if the volume of a cone is 131 cubic centimeters and the height is 9 centimeters, what is the radius of the cone? So I'm going to first start by writing down the formula for the volume of a cone. So the volume is 1/3 pi r squared h. And I'm going to write down the information that I know. So I know the volume is 131, and I know that the height is 9. And I want to figure out what the radius is. So in order to be able to do this, I'm going to isolate this r. I'm going to get the r alone before I plug in any information. So the first thing I want to do is get rid of this 1/3. Well, the opposite of division by 3 is multiplication by 3. And remember, this is all one term because there aren't any plus or minus signs to separate our terms here. So I'm going to multiply by 3, and that's going to cancel out with this 1/3 because 3 times a third is a whole. Okay? But whatever I do to one side, I do to the other side. So I end up getting 3v equals pi r squared h. Now, in order to get the r squared alone, I need to get rid of the pi and the h. So I'm going to divide both sides by pi h. So I'm going to just bring this up here, and I'm going to rewrite this as 3v over pi h is equal to r squared. Okay? And then to get this r alone, I need to square root both sides. So I'm going to square root both sides, and I end up getting r equals the square root of 3v over pi h. Okay, now that I know that r is the square root of 3v over pi h, I'm going to plug in that information. So it's going to be 3 times v stands for the volume, and we figured out the volume is 131. It told us that. Okay, and then I'm going to divide that by pi times h, which is the height, and we figured out that the height was 9. So it's going to be divided by, instead of pi times 9, I'm just going to say 9 pi. Okay, so then in order to figure this out, I'm going to plug that information in. So I'm going to do 3 times 131, and I get 393. Okay, and I'm going to divide that by, now you must put this in brackets because I need to show that I'm dividing by all of 9 pi. So I'm going to divide by 9 pi, close my brackets, press enter, and then square root it, and I end up getting r is about 3.7. So we're going to say the radius is about 3.7 centimeters. Now I want to just do a quick check to see if this is going to work. So if the volume is 1/3 pi r squared h, and I know that r is about 3.7, and I'm going to multiply it by the height, which is 9. So I'm going to type that into my calculator and see what I get. So I'm going to type in 1/3 times pi times 3.7 squared times 9, and I end up getting about 129, which is close to what I'm looking for, but because I rounded this value right here, my answer is slightly off. It's close to 131, but it's not exact. If I had a more accurate r value here, then it would be a little bit more exact. Okay? All right, awesome. Have a great day.